All right, so we'll start by creating a 2D scene. On the node 2D, as our root node, we're going to add a child node, and that's going to be navigation region 2D, and we'll click create. So from here, let's go ahead and I'm going to readjust our screen here. Over at the navigation polygon, we're going to click on that dropdown. We're going to click new navigation polygon. From there, go ahead and make sure that you've selected create points. And then, while you would draw this to the region that you want your AI to be able to move around in, I'm going to draw this in a U so that we can confirm that the AI is actually moving around towards the target rather than just moving in a straight line. So then we're also going to right-click on node 2D again. And this time, we're going to add a marker 2D node. This is going to be where our AI entity is trying to move to. We're going to move it to the right side of the U here. And now we're actually going to build out our AI entity. So we're going to right-click node 2D again. We're going to click add child node, and we're going to type character body 2D. From here, we are going to, again, add a child node. This will be a sprite 2D. We're also going to add a collision shape 2D. And then we're going to add a navigation agent 2D as well. Our sprite node, we're going to click on the sprite node on the right side in the inspector. Under texture, click the drop-down list. We're going to click load, and we're going to select the icon, the Godot icon. We're next going to click on the collision shape 2D. Again, in the inspector where it says shape, we're going to select a new rectangle shape 2D. And then I'm going to scroll in, and I'm going to drag this out to roughly be the shape of our sprite image that we selected. Oh, but in that case, I clicked. Okay, this is our scene setup. For the moment, we will have to come back here after we do the code section. However, this is okay for now. For our character body 2D, let's go ahead and rename this to AI entity. And now we're going to right-click on the AI entity, and we're going to attach a script. From here, we're going to inherit from character body 2D, but the language, we're going to select C#. We'll use AI entity as the name, though you can name it however you'd prefer, and make sure it's in the folder that you prefer. And then we click create. So jumping into the code, our file will initially look like this, having inherited the standard code from character body 2D. We're not going to need most of this, so let's go ahead and get rid of these starting properties. And we can also empty physics process all the way down to move and slide. We'll use move and slide, and we will use physics process. So let's go ahead and start with declaring our class variables here. So we're going to declare a private float called movement speed. We're then also going to declare our essentially our target. So we're going to marker 2D. So a private marker 2D. That we'll call movement target. And then we'll also declare a private navigation agent 2D. And this will be the child navigation agent that we attach to our AI entity. Now, in order to expose these in the inspector, we also need to put export tag above these two. Okay, the next thing that we're going to want to do is we're going to want to create a ready function. This will run on our AI entity as soon as the scene starts. Now, below that, and we'll populate the ready function in a moment, we're going to create a new function called set movement target. This is going to use our navigation agent that we set above, and this is going to set its target position. Okay, now from our ready function, we can go ahead and call the set movement target function. However, we're going to wrap it in call deferred. I'm going to copy and paste the name of our function in, that way I don't misspell it. Okay, so now that that is done, we're going to move into our physics process. So down here, what we're first going to do is check if our navigation agent has finished its movement. For that, we call is navigation finished. If it has, we want to return. If it is not, we want to keep moving towards our target. So we're going to create a new vector 2 called current entity position. And it will be equal to our global position. We're then going to create another vector 2. And this is going to be our next path position. So where the navigation agent is telling us that we need to go. Then, using those two vectors, we're going to begin calculating our new velocity. So this is going to also be a vector 2 called new velocity. Of course, you could name these whatever you would prefer. These are just the names that I have chosen here. So then we get that by subtracting current entity position from next path position. From there, we want to normalize the vector. And then we would like to multiply this by the movement speed that we declared above. And we will also multiply this by the delta that is passed in to the physics process function. We now need to take our new velocity and assign it to our entity's velocity. Since this is a property of this object, you could access this with this as well, as I did here, but I don't believe you have to do that either. I think it works with or without it. And finally, we want to make sure that move and slide is called. Okay, with our script complete, we now need to assign the marker 2D as the movement target, and we need to assign the navigation agent as our navigation agent. Okay, so back in Godot, we want to reload our file, and we'll click Build. Now, this has failed to build, and a couple of things have been identified down here in the output, mainly missing semicolons. If we navigate back to our code, though, we can certainly fix those semicolon issues, but I also made two mistakes. Position, the P needs to be capitalized when grabbing the position from the movement target, and on top of that, new velocity, which is a vector 2, we were setting it equal to a float value, which you cannot do. What we intended to do was to multiply the new velocity by the movement speed and the delta. If we save this and we go back to Godot and we reload the file again and click Build, the project should build with no errors this time. Okay, continuing from here, let's go back to our 2D scene. Let's go ahead and click on our AI entity again, and on the right-hand side in the inspector, we should see 2 slots for the movement target and the navigation agent. Let's go ahead and drag the marker 2D node from the left hand from our scene into the movement target under the AI entity. Furthermore, let's grab the navigation agent 2D node and drag it under the navigation agent slot. If we now run our current scene, which will ask us to save, you can name this anything you'd like. I'll just name it Pathfinding Example. After it builds the project, we should see our AI entity moving very slowly towards our target. If we exit and go back to our code, we can drastically increase the move speed since it's being so significantly reduced by the delta. If we save this now at 1,000 rather than 100, go back to Godot, have it reload, have it build again, and then run the current scene, and we should see our AI entity moving a little bit more reasonably paced, though that could indeed be faster. In order to help us identify what the AI entity is doing in the scene, let's go to Debug, and we're going to click Visible Paths and Visible Navigation. From here, make sure you click on your Navigation Agent 2D node under the scene, and then in the inspector, navigate to Debug. Go ahead and click on for Enabled. When we run the current scene again, we should now see the path that our AI entity is traveling towards the marker and the region that it is moving within. We can help him speed up again a bit more by going back towards our code. I'm going to increment this again now to 5,000 to truly make it much faster. And we can run our current scene again. This should automatically build our .NET project. And from here, we can watch as the AI entity moves through the navigation region towards the marker 2D. As always, thank you for watching, and for more tutorials, please come back to Tundra Feed and Supply Co.